decomposition, you have one thing breaking apart into two things. That one thing is usually an ionic compound, with the subscripts being based off of the charges you find on the periodic table. All right, in order to break things apart, you need to usually apply some amount of force. All right, you're going to need heat to break things apart, or maybe an electrical current in the form of electrolysis. All right, so basically, you're trying to undo an ionic compound. This is a stable thing, and so it's just like getting a refund. All right, the cation A+ wants a refund on its electrons, but just like in real life, you're trying to get a refund. There's usually some amount of work involved. You have to show a receipt. You have to show your items in good condition. You gotta put in energy to get that refund, and that's what's happening here. But with enough heat or electricity, triangle being the symbol for heat, you'll get those electrons back. The metal gets its electrons back, and the non-metal is without its electrons. Okay. At the Chem 101 level, we usually have decomposition going into elements. In reality, it's pretty hard actually to find many examples of this happening. More common decomposition is you're not going to have a clean break into elements. Often you're going to make like an oxide or a hydroxide or something. But that's not the focus of this video. Okay, so we will cover examples where you break apart into elements. And the subscripts on these elements, it's going to be a 1, usually for everything, but with the exception of these diatomic elements. And plenty of times you will have these diatomic elements. So that would be H2, N2, O2, F2, Cl2, Br2, I2. All right, a neat little trick, if you haven't seen this, to find your 7 diatomic elements is to realize that 6 of the 7 are right here on the periodic table. All right, and in their elemental form, you would give them a subscript of a 2. So 1, 2, 3, 4, 5, 6 of the 7 look like the number 7. And then the last one is hydrogen, way over here. I always envisioned this as a hockey stick. Someone's doing like high sticking, and the puck went flying really high. That's somehow always been the image in my head. All right, so again, subscripts 2 if it's one of the diatomic elements. For everything else, it's usually going to be a 1. There's a few exceptions, like sulfur being an 8, and maybe phosphorus being a 4, but we're not going to dwell too much on those exceptions. All right, on to examples. All right, example number 1, we'll start with one of the most industrially important decompositions, which is the decomposition of water into its elements. All right, so we'll start with water. Water is a liquid. And to decompose water, you're going to need to apply a voltage, some electricity, and you'll need an electrolyte. All right, a common safer electrolyte compared to other electrolytes would be potassium hydroxide. Not to say it's completely safe to work with, but safer compared to, say, sodium chloride, where you would make some chlorine gas byproducts, maybe even some elemental sodium. So not the safest route. This is the preferred route. Okay. Let's erase this. It's just like there in the mix, but it's not actually a part of the reaction. You can think of it as like kind of a catalyst for the reaction. There, but not being used. It's a simple way of thinking about a catalyst. All right, anyway, let's break it apart. So we get hydrogen. You have to write the H2. Not because there's a 2 there, though. That's just a coincidence. And then we have to write oxygen. And the oxygen that we breathe, just like the oxygen here, is O2. All right, so that's what I was referring to here, subscript of 2 if you have a diatomic element. So there's our H2, there's our O2. All right, so there it is. We broke it apart into elements. Now we just have to balance. All right, we have 2 oxygens there and then 1 there, so we need to fix that imbalance. But now we have 4 hydrogens there, so we put a 2 there to fix that imbalance, and this reaction is done. Another way you could have done this could have written out the elements, and then to balance out the oxygens, you could have put like a 0.5 here, or like a 1/2, and that would get you to 1 oxygen on this side. And then most Chem 101 curricula don't allow you to leave fractions or decimals, so you would just multiply everything by 2 here to eliminate that. And of course, you'll end up with this equation here. All right, that was example 1. Example number 2, we're going to decompose mercury 2 oxide into elements. All right, they gave us a name. They didn't give us a formula, so we're going to go to the periodic table. Oxygen is right here in the 2- column. Again, not a bad idea to go 1 plus, 2 plus, 3 plus, 4 plus, 3 minus, 2 minus, 1 minus, 0. On your periodic, oxygen is a 2-. I mean, oxygen being 2- is so common. I often say to my students, 2 plus 2 is 4. The sky is blue. Oxygen is 2-. In fact, like it's so uncommon. Really, the only like example I can think of like immediately where oxygen's like not a 2- would be like peroxide and hydrogen peroxide. It's a 1- there. Otherwise, it's 2-. All right, and then for the mercury, it's Hg. That's element 80 on the periodic table. Now, mercury can be a 1+ or a 2+. Okay, here's mercury. It's a transition metal. Most of the transition metals have more than one possible charge, so they would have to tell us the charge. And they did. So that'd be Hg2+ and O2-. We only need one of each to make a chemical formula that's charge balanced, Hg and O. All right, so we're decomposing HgO. And that requires heat. I wouldn't expect you to know that offhand, but it does. I mean, generally speaking, you're going to need some type of energy input to break things apart. Mercury is a metal. Now, mercury is a liquid at most room temperatures on Earth. Okay, mercury oxide is a solid. Most ionic compounds are solids, so you're pretty safe putting an S. And then we're going to make oxygen gas. But oxygen is a 2, so we need to put the 2 there. All right. You could have done, like, to balance this, you could put a 1/2 here or a 0.5, or I'm just going to go with this. I have 2 here, so I need 2 there. That makes 2 mercury, so I put a 2 there. And that reaction is done. One more example. All right, and I thought for last example I'd bring in a weirder one. We'll do some noble gas chemistry. Xenon tetrafluoride, we'll decompose that into elements. Actually, no, I think this is a solid. Yeah. And then apply some heat, and then we'll get... All right, so xenon's a noble gas. So if you decompose it, it'll be by itself. Whereas fluorine's one of your diatomic gases, so you have to write it as a 2. All right, looks like all I need is a 2 there, and we're balanced. All right, so the long story short with decomposition is unless your instructors make you learn about oxides and carbonates and those sorts of decompositions, we usually just talk about decomposing the elements, which means you need to know how to write out your elements. Again, most elements, you're going to just write a 1, but if you have one of the 7 diatomics, then you'll need to give it a 2. And then you just balance like usual. All right, thanks for your attention and have a good one.